A smartphone charger can deliver tens of watts of power, while a wireless communication signal may contain only a tiny amount of energy. So why can a weak signal carry a video call, GPS navigation, or internet data across the world? In this video, you'll learn the critical difference between signals and power, a concept that sits at the heart of electronics and RF engineering. In electronics, the terms signal and power are often used together, but they represent different objectives. Power refers to the transfer of electrical energy from a source to a load. Its purpose is to provide energy that can perform useful work, such as charging a battery, driving a motor, or powering a circuit. A signal is different because its primary purpose is to carry information. That information might be voice, video, sensor data, digital bits, or control commands. The value of a signal is not determined by how much energy it carries, but by how accurately the information can be delivered and interpreted. Although both signals and power involve voltage and current, engineers treat them differently. Power systems focus on efficient energy transfer, while signal systems focus on reliable information transfer. Understanding this distinction is essential before moving deeper into communication and RF engineering. Power transfer occurs when electrical energy moves from a source into a load. The amount of transferred energy depends on voltage, current, and time. In a charger, for example, the goal is to deliver enough energy to recharge a battery as efficiently as possible. Signal transfer focuses on information rather than energy. Information can be encoded into changes in voltage, current, amplitude, frequency, or phase. A receiving circuit detects these changes and reconstructs the original message, whether it is audio, video, or digital data. Because information is the priority, signals can operate at surprisingly low power levels. Even weak signals can successfully communicate large amounts of information when noise is controlled and the receiver is designed to detect small variations accurately. Imagine a truck delivering construction materials to a building site. The value comes from the quantity of material being transported. This is similar to a power system, where success is measured by how much energy reaches the destination. Now imagine a letter containing important instructions. The paper itself has very little value, but the information written on it may be extremely important. This resembles a signal system, where the information matters much more than the energy used to transport it. This analogy explains why a tiny wireless signal can support a phone call or internet connection. The signal does not need to deliver significant power. It only needs to deliver the correct information to the receiver. Modern electronic systems contain both power paths and signal paths. A smartphone battery delivers power to the device, while communication circuits process signals carrying voice, data, GPS information, and wireless network traffic. In RF engineering, signals travel through amplifiers, filters, mixers, transmission lines, and antennas. Engineers work hard to preserve signal quality because distortion or noise can damage the information being transmitted, even if sufficient signal power is still present. Understanding whether a circuit is handling energy or information helps engineers make better design decisions. Many engineering challenges involve balancing signal integrity, power efficiency, and system performance simultaneously. Consider a Wi-Fi router at home. The power supply delivers electrical energy that keeps the processor, memory, and communication circuits operating. Without this power, the device would immediately stop functioning. At the same time, the router continuously transmits and receives wireless signals. These signals carry web pages, video streams, emails, online gaming data, and countless other forms of information. Their purpose is communication rather than energy delivery. The same concept applies to smartphones, satellites, radar systems, and RF communication equipment. Engineers must manage both power flow and information flow, making the distinction between signals and power one of the most important ideas in electronics. So today, we learned that power is used to transfer energy, while signals are used to transfer information. Although both involve voltage and current, their engineering purposes are fundamentally different. In the next lesson, we'll explore ideal versus real components and discover why real electronic components never behave exactly like the perfect models shown in textbooks. If you found this useful, like the video, subscribe, and follow for the next lesson.